Good afternoon, everyone, and welcome to today's session. My name is Esnam Tamaklo, and I'm a member of the Groundwater Division's Young Professionals Committee based in the Western Cape branch. I'm delighted to host today's session in celebration of the World Water Monitoring Day, a day that highlights the importance of understanding, monitoring, and sustainably managing our water resources. Today, we'll hear from two experts in the groundwater management industry, sharing insights from research and practice that is relevant for both professional and young geohydrologists like ourselves. Just a few housekeeping rules to note to make the session for today smooth. Firstly, I'd like to ask that we please switch off our cameras as well as our microphones during the presentations, and to try and hold all questions until the end of the presentations or write them down in the chat box. After both talks, there will be a dedicated Q&A session. Lastly, I'd like to ask that in the chat box, you type your full name and organization so that we can capture this information for the CPD points. Let's begin with our first speaker. Dr. Garthia Mahed, Head of Geosciences at the Nelson Mandela University, is a professional who has a PhD that focuses rather on the fractured rock hydrogeology and has an extensive experience in mining, in shale gas research, consulting, as well as sustainability. His work has been recognized with numerous awards, including the 2023 Merging Innovations Excellence Award. Over to you, Dr. G.
Good afternoon, ladies and gentlemen. Can you hear me clearly? Everybody's okay?
Yes, we
Well?
can.
Awesome. Thank you very much. I'd like to thank the Groundwater Division, the GSSA Young Professionals for this opportunity. This presentation, like Esnam said, is obviously in line with World Water Monitoring Day, but also gaining on all the experiences that we've had over the years from the perspective of developing sampling and monitoring protocols for various clients, including the Water Research Commission. I always like to start off with kind of like a framework, just a way of thinking, right? And that begins with, why do we sample? Now, Banksy's latest work, it was sprayed upon, the walls of one of the judicial buildings in the UK is a very good example, right? Here you have the law or lawmakers and policymakers beating us into submission. And in many cases, this is the reality. We sample so that we're able to fulfill certain requirements, right? We sample so that we're able to write a quarterly report or meet certain targets. But we actually need to be reframing this from the perspective of not just sampling for that purpose, but sampling in order to better understand the system. Now, it boils back to sampling as a science. If you're really interested, one can go read the work of Piaget, who's the modern day father of sampling. And you can begin to understand how sampling, especially sampling in general, and then sampling for environmental factors, and eventually sampling for groundwater is developed as a science. Now, in the past few years, there's been extensive work done around this. There's manuals, there's protocols, there's ways to do things, right? And this is why we normally, before we go to the field, hand over manuals of this nature. This was done by John Weaver in 2007 with Lisa Cava and Sip Talma for the Water Research Commission. There's been a more recent version. And one can think of this as kind of like a cookbook, when I need to look at how to sample, what to sample, when to sample, and in turn also developing that idea or thinking behind sampling. This is normally the first point of departure. Now, like I said, I'm giving you this from the perspective of the development and methodology, as well as trying to understand or give you the thinking needed behind groundwater sampling, because it's not just a case of I'm going to take a sample and then send it to the lab. and get the results, right? We need to know what, why, and when. And that's critical. And this is where protocols come into place. Now, there's been a lot of work and a substantial amount of literature reviews and, theses, master's PhDs, as well as documents developed around this. But fundamentally, from the perspective of taking hydrologic measurements all the way to sample storage and afterwards analysis, there are systematic steps put in place for this. But one needs to begin to understand that not in every situation will all of these apply for everybody. Because we found from experience that in certain environments, for example, your ability to be able to remove stagnant water from a well and purge it due to low hydraulic conductivity values, you're finding that well recovery is taking extensively long, right? So sometimes in certain instances, you have to adapt the situation to better improve the way you take your samples. Now, generally, once our samples have been taken, we as hydrologists and geologists just send it off to the lab, and we don't really care what's happening, right? As long as in that big black box in the lab, out comes the answer. Now, one has to be very careful, and this is why I always raise this point, especially with non-chemists. And here's Mr. Bean himself, and trust me, I've worked in many labs. There's always one of these guys. And sometimes it's a case of the results coming out, and they are extremely bad. And you start questioning yourself, not realizing that the protocol that you've developed or that you followed was perfectly fine, and it's actually an internal issue in the lab, right? Like this guy is following protocol, but doesn't actually know what's happening. So this is why I'm saying from the beginning, it's about asking the right questions when you're sampling and following the right procedures and treating your sample appropriately. Because from a water resource management perspective, especially if it's a case of you're a consultant or you're on a mine and there needs to be some kind of reporting, you start with that basic question of, what is the information that I need? Right? And this is why I say you have to be systematic about it in your thinking. Right? And that's generally most probably why many a times you'll see the chemists are so methodological. They have these cookbooks around how to sample and developing sampling procedures and developing the needs around these things. And this kind of cycle or assessment can guide you in terms of developing and utilizing the information that's coming out of that sampling and monitoring, protocol and procedure that you are consistently following every month, every quarter, bi-yearly, whatever the case may be, so that you're able to utilize it to feed it into a system, or automatic system, that can give you the ability to be able to make good decisions. And that's what it's about at the end of the day, really. Because fundamentally, monitoring is really just sampling on the repeat track. And if you don't know what you're sampling or monitoring, and you're able to measure it, like these two scientists here, they're looking at a graph and they're telling themselves, oh, okay, it's either an East Coast quake or the latest from Wall Street. And sometimes we've dealt with people who are not necessarily water scientists, who have the data, who are unable to interpret that data properly, or even analyze it or treat it in such a way that it's ready for interpretation. So sampling on its own is great, but the ability to be able to use what has come from that sampling exercise is just as important, right? Then developing, obviously, that monitoring protocol so that you're able to say, look here, from a preliminary assessment of the current situation that I'm sitting in, right? Am I asking the right questions in terms of my ability to be able to understand the system holistically? Because when you do go out there and sample, and you're sampling a river or a well or a soil mass, whatever, that is one point. You need to look at this holistically. How do we extend beyond that point what's happening on the catchment scale, what's happening on a wider, scale. Can I map it? Am I able to take those results and refine it and then give good decisions or management decisions for my clients? Right? All these things become very important. I mean, we worked so many projects, especially across Africa and the Middle East for petrochemical companies, and you will see sometimes the sampling and the monitoring is so inconsistent. There's such massive gaps in the data. Sometimes they sample this year and they won't sample next year. And they'll sample twice in the following year and 3 times in the year after that. And you're unable to make good decisions. And this is why when you're designing your monitoring program and its components, right, you need to have a deep appreciation of what the needs are and balancing in that in turn with your budget requirements to determine whether these things are feasible or not. As much as, yes, it's important, I need to report as a consultant, I need to be billable, but what does the client or that specific person actually need? And is it plausible or feasible? And then you're able to look at it holistically, right? Because at the end of the day, yes, it is about obviously costing, and you have to, make some kind of margin on that. But you need to think about this in the bigger picture as well. And that's why when you're setting up that monitoring network, we don't just look at it from the perspective of only sampling for quality. Because 9 times out of 10, especially as a young geo or a young hydro, you like our sample. Now we take a sample so we can do chemistry on it. Yes, that's important. But when you're also monitoring long-term, there needs to be external parameters thought of. I'll give you an example. We've been working in the lab on and off sampling water and looking at it on the perspective of its impact on certain experiments. And you very quickly realize that the temperature of that water has a major role. Now, we hydros and geos, we get that. But I'm working with a lab in physics and they don't really understand or see that. So that value add that you bring in, never undermine it from the perspective of, I see it in this way, and I think there's value that can be added like this. Right? So with all that said, one has to really look at aspects around factors related to specification of data needs. What are my parameters and frequency that I need to be looking at in terms of sampling and monitoring? And then looking at that total groundwater monitoring program. Now, it's been done before in many places. I mean, while I was doing my MSc, we worked on a project for the Water Research Commission, and we had to do this kind of, what are the topics covered in different kind of monitoring protocols and sampling protocols. And you'll see this has been coming on for the past 40 years from the work of Barcelona and pools in Barcelona in the 80s, all the way up until the work of Weaver that we've just showcased earlier before, as well as some follow-up work here on the right. You can see Gomo et al. That recently re-looked at the groundwater sampling manual and developed it. And in 2012, 2013, a group from UWC, or the UNESCO Chair for Hydrogeology, developed a monitoring protocol, particularly for radioactive elements in Beaufort West. So there is a set of available literature for students and practitioners that are looking to leverage off of this information. It's been done before. The research is the ability to be able to stand on the shoulders of giants and then move forward. And that's the state of the science. In many instances, you will see, and it's become a big thing in recent years, whereby these setups for low flow samplers, low volume purging, all these kind of things are being sold. And it's hundreds of thousands of rands. And there has been work done around this extensively in terms of comparing these different types of sampling methods. So one just has to look at what is my situation, what's the context I'm operating in, and how do I go about in terms of optimizing my sampling and monitoring frequency to get the kind of results that are reflective of what's happening in the subsurface. All right? And just remember, especially if you're out there in the field, sometimes things happen and you have to basically, as we would say back in the day, pull some sort of MacGyver move, whereby you literally using what's around you in order to either pull that sample out or store it appropriately, or ensure that the integrity of that sample is kept intact. And this is a field photo a colleague of ours saw at one of the farms that they worked in, where it says trespass will be shot, the others will be shot again. And this is the kind of things that happen, you know. And I wish we could do this to some lab analysts, but we can't because of the way they're treating our data, or our samples for that matter. And this is my point of departure that I just want us all to be aware of, is when we are sampling, it's critical to understand the context that we're operating in. But it's even more important for us to understand, what does the lab need from me so that they're able to analyze the sample in a manner where they're reducing their errors. And this, to me, that is the takeaway message for us as hydros and geos. Because many a times we're just taking the sample and we're sending it off into the lab, and whoever's operating at ICP, I don't care as long as I get the result out of it. Be aware of who your technicians are, what they are doing, how the sample is treated in that space, and what is the kind of information that's coming out, or data that's coming out of that. And you will realize very quickly that the way you treat those technicians and people in that space in particular, and the quality of the data, the quality of the treatment of the work that's going into your sample, are directly correlated. And with that said, I just want to say once again, thank you to everybody for being here today. And that's my presentation, Isana. Over to you.
Thank you so much, Dr. G, for sharing your expertise. Again, if you have any questions, can you please write them down in the chat or raise your hand at the end of the sessions, because we do have an allocated Q&A session. Just another point for those who had joined in late, please do not forget to type in your full name and organization in the chat box so that we can capture this information. Next, we have our second speaker. Dr. Magingi is a hydrogeologist at the Department of Water and Sanitation with expertise, in groundwater management, resource assessment, and managed aquifer recharge. She holds a PhD in hydrogeology, in hydrology from the Free State University, and was recognized as one of the Mail and Guardian top 200 youth of South Africans in South Africa, or in environment, in 2023. Over to you, Award One.
Okay, thank you so much, Esna, for that introduction. For those who don't know me, I'll just open my camera. I hope you can see me, and I'm going to close it again for bandwidth. Okay. Good afternoon, everyone. As Esnam has said, I am Award Magingi from the Department of Water and Sanitation. And yeah, I'll just give you a little bit of information on one of the projects that we have conducted as part of the Strategic Water Sector Cooperation between Denmark and South Africa. I'm not sure what this laptop is doing, but Esnam, can you please indicate that you can see my screen?
Yes, I can.
All right. Thank you so much for that. As Dr. G has mentioned, if we talk of monitoring, I bet most of our fellow young professionals, when we talk about water resource monitoring, specifically groundwater monitoring, we often think of water levels and water quality. And my question to you today is, if you monitor this vandalized borehole, will that get you water in your tap? And obviously the answer is no. And that's what I'm going to focus on today. The other aspects of monitoring, and not only water levels and water quality. What else do you need to monitor so that at the end of the day, you have supply? As you've seen my title, it's mostly focusing on sustainable water supply. And we all understand that groundwater monitoring is the backbone of groundwater management, as the previous speaker has already mentioned. And this is a groundwater management framework from the WRC 2011 report, I think, and I've just highlighted here amongst the components of groundwater management is the aquifer utilization, focusing specifically on well-field operation and maintenance. And we're going to really focus mostly on the well-field operation and maintenance. And these are just the guidance documents that are available in our DWS website, as well as the WRC search engine. So if you can just search groundwater guidance documents, most of the groundwater guidance documents, but I have just picked these two because they really focus on monitoring, linking that to groundwater management as a whole. And I've also just highlighted some of the groundwater management principles. You can find them in much detail from Finance's MSc dissertation. But I've highlighted monitoring because, I mean, it's World Monitoring Day. So we're going to focus more on the monitoring. But at a later stage, I want you to remember these principles and how all of them actually link to monitoring. And most of them, they're actually embedded in monitoring. Okay, so in South Africa, I think we all understand that when it comes to groundwater management, actually just groundwater, it's still lagging behind, surface water because we rely more on the surface water. And if groundwater is lagging, that means even the management of it is still lacking. And I've just highlighted two gaps here, which is the lack of effective groundwater monitoring by all stakeholders, as well as lack of effective groundwater management with emphasis on operation and maintenance of groundwater infrastructure. And I won't dwell much onto this, but these are some of the challenges that are linked to operation and maintenance. I think we all know them. Vandalism is up there, lack of skilled staff, especially in local government, and a whole lot of, challenges when it comes to operation and maintenance of groundwater schemes. And again, if we are looking at groundwater scheme management, you're looking at the operations, the maintenance, and the monitoring, and what are the management tools that are there. They're actually focusing on the groundwater quality, groundwater quantity. But what's mostly important for today's presentation is the fact that you can also see in third point, the management tools, the operation and maintenance and monitoring protocols for each type of scheme. So that operation and maintenance, as much as you have your groundwater levels and your groundwater quality monitored properly, you analyze your data and. If you do not have that in place, you will still not get water to supply the industries, water to supply the communities and so on and so forth. And then these are some of the water use license conditions that can actually assist in groundwater scheme management. I think they are very much effective. There can be improvement, but yeah, the license conditions and also compliance monitoring. But again, if we look at the monitoring objectives, as this previous speaker has already mentioned, you need to understand your objectives. Why are you monitoring? And the type of monitoring that you need to do. Is it a routine-based monitoring? Is it an event-based monitoring? Or you just want to get a baseline? And under these early warning systems that actually prepare you for proactive and adaptive management of groundwater schemes, you have your water quality monitoring objectives. I think that those ones, they become very much clear. Water level monitoring objectives. But what's still lacking is the operation and maintenance monitoring objectives. In most cases, even if you have those, but they are not being complied to. And these are just some of the examples of water monitoring and water quality monitoring objectives. And the equipment that you use for that, I think we're all familiar with that. And then also with operational monitoring objectives, you have abstraction volumes, whereby you need to actually understand how much are you abstracting. And in most cases in the country, that recommended volume for abstraction, in certain cases, people, they just abstract as much as they want. And then you realize that the borehole actually fails, and it's not the resource that fails, it's the actual infrastructure, it's the actual borehole that fails. And that actually links to the maintenance plans, because if you're monitoring the maintenance of the actual borehole, then you will understand what needs to be fixed, how is the borehole performing, and if the flow meters are working or not. In certain cases, the flow meters are not even working, but abstraction just continues, you know. And also that is linked to power consumption and all the other parameters under operation and maintenance. Okay. Why is it not moving? Okay. So if we're talking about groundwater scheme management, it needs to be an adaptive scheme management, whereby you monitor, you model, and you manage. And this principal groundwater management task, they tried to actually highlight, it was also taken from the WRC 2011 report on the groundwater management framework. It also tries to highlight who needs to do what when. So with the water services providers, they actually need to monitor, even though most stakeholders, they actually monitor. And then you need to model. And the Water Services Authority, they manage the resource. And the cycle just goes on and on and on and on. It doesn't stop anyway. Whether you start with management and then you monitor and model, or you model, manage, and monitor, but you need to actually adjust according to the specifications of the scheme. And I won't go into much detail in here. It's highlighted in one of the guidance documents that I've shared. And I said you can get those from the DWS website as well as from the WRC search engine, but it just gives you a highlight of why do you have to actually monitor power supply, for example. You have monitored your water levels, you have monitored your water quality, but now why do you have to monitor pumps, for example? Why do you have to monitor storage? It gives you all the nice details in terms of how you can do it, how often you can do it, who must do it, and you know why, and what to do when. And then this one is for monitoring. I think it's what we are familiar with the flow meters and abstracted volumes. Also, why do you need to do it, what to do, and who does it. Now, if we go back to those groundwater management principles that I've highlighted, you can see I've given you 12 principles that you can get from that the MSc dissertation. But what's important here is that you also monitor protection. You also monitor use, because under protection, that's where you get your over abstraction. You also get water quality. And again, under monitoring use, that's where you will get an indication if you're over abstracting or not. And then you also monitor infrastructure and you monitor operation, which actually makes sense for today's celebration, which is World Water Monitoring Day. Because, I mean, as you can see from these principles, it's basically like you can't do anything without monitoring, especially when it comes to groundwater resources, because you can't even see them with the naked eye. So you basically need something that's going to tell you how the aquifer is behaving and what to do. And then now, after that whole lot of background on groundwater management, I'd like to just take you through what we have done in Modimolle-Mokgopong local municipality, looking at well-filled optimization, and in certain cases, it was just one borehole optimization. So I need you to actually remember, you know, the whole lot of groundwater management principles, and as we go through this presentation, maybe you will start picking what sort of action plan you'd come up with. Maybe your action plan will actually correlate with ours. And as you can see now, I have a flag of South Africa and Denmark, and that is because this study, it was actually done under the Strategic Water Sector Cooperation between Denmark and South Africa, between the Water Use Efficiency Thematic Area and the Groundwater Management Thematic Area. And the main objective was actually to develop procedures for well field, and managing the well field in a sustainable manner. I think we like using this word, water supply in a sustainable manner, management in a sustainable manner, but what does it actually mean when it comes to well fields? So again, if we look at this specific study area, it has 5 systems. So the Modimolle system, it's dependent on surface water with augmentation from groundwater. Mokgopong, it's more or less the same. And then there are 3 smaller systems, Rutan, Alvater, and Alman, that are dependent only on groundwater. I won't bore you with much detail on the geological and hydrogeological setting. However, I just wanted to highlight that the whole municipality is actually sitting on the basalts of Letaba Formation of the Libombo group. And then this is just the hydrogeological setting of the area, which is actually fractured and intergranular aquifers. And then this is the groundwater supply system. This one is for Modimolle area. I just wanted to show you how different these systems are. So with the red dots, those are the non-functioning boreholes, and then the green ones are functioning boreholes. And you remember that this one actually relies on surface water with augmentation from groundwater. And this one is the Mokgopong area, same or similar situation as the Modimolle area. It's just that the boreholes in Modimolle, they are in town. And then this interesting one, which is Valvater, you can already see the irrigation, the agricultural setup around those boreholes. And only one borehole wasn't actually functioning at that time. And I think really vandalism is like a major problem when it comes to groundwater, because these boreholes are actually situated in a private land, so in farms, and the security there is higher than, you know, where they are in Modimolle and Mokgopong. And then this is just to show you the smallest, I think this is one of the smallest schemes where they are supplying from the 2 boreholes. And luckily, when we visited, those 2 boreholes were both working. Now, if we go back to borehole optimization, and you look at the problem, what's the problem in Modimolle Mokgopong local municipality? Or what was the problem at that time? Because this was a 2021 project. Already there, you see insufficient provision of water from the bulk water supplier, as well as the municipality's own sources, and a water distribution loss of nearly 40%. Now, already, this baby here, operation and maintenance monitoring objectives, it becomes a culprit, because as much as you can monitor the other 2, but you have that loss of nearly 40%. And that actually should ring a bell that whatever the problem is in these boreholes, it has something to do with the operation and maintenance of the infrastructure. And then if we look at the key elements of borehole optimization, you look at the design and the construction, and that's very important, because how your borehole was constructed and, you know, sited, it becomes very important in its efficiency and sustainability. And you also look at monitoring, operation, and maintenance. I think there are other key elements of this, but I've just highlighted these ones. And in most cases in Modimolle Mokgopong local municipality, you could see some of the boreholes with some of the information captured. But looking at the borehole status in that municipality, already you can see that if you look at the borehole itself, if it's functioning or not functioning, you can see it's only 3 boreholes in Mokgopong, the actual borehole. And if you look at the equipment, and that could be linked to a borehole that has collapsed or it has dried up and there needs to be further investigation on that. But if you look at the equipment dysfunctioning, you can already see that the resource here may not be the problem, but the equipment, the infrastructure is the bigger problem. And now you sort of channel your action plan towards the equipment or the infrastructure of the schemes. And then there were also tests conducted, and we just categorized all the boreholes based on the recommended yield. And the main reason for that, honestly, is to help the municipality prioritize their efforts on maintenance. And everything is linked to money. Where do you get the most water for? We try to actually put some of them category A, some of them category B, but you'd really like to be focus more on the category A boreholes. And then there were also water quality tests done as part of this borehole status. And there were no major water quality issues, only nitrate that was elevated around the Mokopong area, and all the other areas, they were actually good. And then you also now start to zoom into the installations, looking at the pumps, looking at the electrical installations. And then you can already see that there is 9 boreholes that actually have good conditions of electrical installations, and 22 of them are in poor conditions. And this is just some of the factors that were considered and evaluated and included as part of how safe the boreholes are. So I tried to actually, the top one and the bottom one, that's Mudimule, and then Mokopong, and then that's Valvater. So already you can see the kind of security that, remember, those are the boreholes that are in private land. And these ones, as much as you would like them to be accessible, but you also need to now consider vandalism issues, So that's why you will find that in Mudimule, most of the boreholes, they're actually under the ground, they are built to be in the subsurface, if I can just put it that way, so that you try to secure them from vandalism and all the equipment that's there. And then the action plan now that was actually developed considering all these installations, all the other factors that actually contribute to the status of the boreholes in this municipality. The main focus was basically on the activities that you need to address now, and also project in 5 and 10 years' time, what sort of operation and maintenance plans, and actually implement those plans and not just have them in place. What sort of those plans do you need? And then there was also some money attached to that, because when you're doing operation and maintenance, there needs to be, funding. So with this, it actually goes in much detail, but it's a tool to actually assist the municipality to say, instead of drilling more boreholes, what can you actually fix and get some of the groundwater demand that is required, whether it's this year or in 5 years' time? What sort of activities that you need to address now, where to channel the money so that you can fix some of the problems now instead of drilling new boreholes. Okay, so with this, we also had some recommendations at the end, just for future considerations for the municipality to basically harmonize the installations, the infrastructure that they have, so that when they have the operation and maintenance plan, once you implement it in one area, it becomes easier to actually implement it in another area within the municipality. Also, there were some capacity issues within the municipality. Those were also highlighted for consideration. Again, monitoring plan, and actually implement that monitoring plan, not just have it as a plan for data collection, so that when you actually do a study at a later stage, you have information. And with that, Thank you everyone who has attended this talk. I hope I managed to cover everything in time.
Thank you so much for that insightful presentation, Awodwa. Just for the audience out there, if you have any questions, I did see a few in the chat box, but I just wanted to open the floor up now for questions. I have seen a few from Harland. I hope I'm pronouncing that correctly. Can you please speak on the challenges faced by the DWS in monitoring groundwater? Borehole data from NGA is scarce. I'm assuming that's for you, Awodwa.
Okay, the monitoring challenges within DWS, I think the major challenge, not just within DWS, is coordination from all the stakeholders. I see someone is actually not.
I'm sorry, can you please mute yourselves?
Okay. Yes, Esnam, I think it's not only within. Okay, you've muted me as well. But I think it's coordination, really. It's coordination from all the different stakeholders, from all the different organizations that are monitoring. I think it's basically accessing that data. And I think it's one of the challenges that have been highlighted a lot. And through the regulations, maybe that can be addressed and resolved. But I think coordination is just the main challenge within the water sector when it comes to groundwater resources.
Thank you so much for that, Awodwa. Dr. G, there are two questions here. One from Harland is, what procedures would you advise for quality assurance and sampling? And the next question from Avela is, how can citizen science be incorporated in groundwater monitoring to improve data collection and public awareness?
Okay, so I'll go for the first one, quality assurance, right? You have to think of this like a chemist, right? From the perspective of quality control. So most chemists in the labs have QA, QC, right? Quality control, quality assurance. And you have to take it from the point of my instrumentation that I'm sampling with, is it clean? My bottles, are they clean? My lines from my pump, are they clean? Have I ensured that my preservatives reagents are in order? Is my cooler box at the right temperature? Is my storage facility clean? Are my bottles labeled appropriately? Is the analyst in the lab, are they trained properly to handle the samples? Am I handling my samples properly? It's such, you have to be, I joke with the chemists and I always tell them, you guys are so pedantic, but there's a reason, because that leads to things like cross-contamination. It leads to your samples, having issues further down the line. And then when your data comes back, 100% of quality assurance on the data itself, the statistical tests can be done, all right? That one can really look into. I mean, there's a substantial amount of work over there. I see, there's one can look at James Drever's The Geochemistry of Natural Waters. There's Hems book. There's a whole bunch of groundwater books that have come out recently on the groundwater project that you can look at in order to help you with those kind of things, right? Then the second question from Avela, and it's a very good question. And there's been a lot of work done around this recently, especially by the African Earth Observatory Network, or AEON, here at Nelson Mandela University, where they're looking at citizen science. And there's a very big social component to this. Now, us as scientists, we don't always understand the mechanics of psychology behind that. And it's very important to involve people, with those kind of backgrounds, as well as, human geographers. And we begin to understand that, number one, firstly and foremostly, training people properly needs to be very high on the list in terms of involving people with citizen science. Because if they're not trained properly and don't understand what they're doing, nor if they don't understand what's the importance of what they're doing, then there's no buy-in. There's a project that we're busy with here in the Eastern Cape that Aon undertook, particularly related to shale gas, but as well as just general environmental monitoring for people. And that people component or aspect can be so unpredictable. But if you do that properly and you get it involved in such a way that those people have buy-in and they know, if I don't monitor every month or take a level or whatever the case may be, this puts my water resources at risk. If the people can understand that and they can begin to do regular monitoring, even if it's simple water depths or whatever it may be, using their cell phones and updating or making sure that there's airtime on the SIM cards that are sending the data from the loggers, whatever the case may be. If we can get that buy-in proper, that can definitely improve data collection. It's more a case of first making the public aware and then improving data collection. I hope it answers the questions for both of our colleagues.
Thank you so much, Dr. G. Awodwa, there are two more questions for you, sorry. One being, did you look at the groundwater balance and sustainability, especially on the areas where SW and GW are used for water supply? And that was from Colin. And another one for you is, there's a third one as well, I do apologize. Are there any future plans to update the NGA? Are there monitoring programs and other stakeholders involved in such a process? And then last question is, how do you incorporate the municipal stakeholders in such cases so that they can buy into these projects, beyond the funding period?
Okay, let me start with the groundwater balance one. So after we have, we sort of had a PSP to conduct some of the work, and that was yield testing the boreholes, because there was no information or data in any of their databases. So we did look at the groundwater balance, but you realize that in most cases, especially in Modimolle and in Mokopong, where surface water and groundwater is used, that in certain cases, I'm just opening the report now, there is use of groundwater more than, in other seasons. For example, in December, you get a high use of surface water from the Donkerport plant, because you remember that I said they're using surface water and groundwater. So maybe they get a lot of water from the plant during wet seasons, but during dry seasons, they actually use more of groundwater. They pump more from groundwater. And when it comes to sustainability, if you look at the recommended abstraction rates, you realize that they are pumping way more than what is recommended, and that's not sustainable. That's why you'll find the pumps, they also have issues, because now you are abstracting more than what the aquifer can actually yield. And one of the issues in the area is that, I think I highlighted them in the recommendations, that some of the boreholes are really low yielding boreholes. So if you force them to actually produce high volumes of water, then you are subjecting those boreholes to failure. So when it comes to sustainability, no, there are recommendations to actually operate and maintain the borehole so that they can have a longer time span, but at that moment, there was no such. And then when it comes to the future plans to update the National Groundwater Archive and the monitoring programs and other stakeholders involved in such processes, honestly, I cannot confirm nor deny that there are any future plans. However, I was invited today in integrated provincial water monitoring for Gauteng, and I do believe that even other provinces, they are actually looking at their monitoring network and how that can actually be improved, and that will really feed into the NGA should that process be finalized sooner. And if the stakeholders are involved in such processes, yes, because after the discussions internally, then the provincial offices, they go and engage external stakeholders, external local stakeholders in such processes. So there is something that is currently happening when it comes to reviewing monitoring networks. I'm not sure if some of my colleagues here from the regional offices can add to that, even if it's in the chat, but I do understand that Gauteng specifically invited me to attend that meeting, and unfortunately I couldn't. And the involvement of municipal stakeholders in these projects, we actually invite the municipalities themselves. Actually, we don't invite them. We go to them. We go to the municipalities. We work with the municipalities from the onset of the project. And at the end, we have sort of like a stakeholder engagement where you translate the science behind what we have done to actually assist the municipality to make decisions on what you have discovered. So I could say there is involvement of stakeholders in these projects, but that's through the municipality, because as DWS, we can't just go straight to communities, for example. There are certain stakeholders that we can invite, but when it comes to the communities, we rely mostly on the municipality. And yeah, I think when it comes to the Modimolle Mokgopong case study, we have presented that and they received it very well. And I think what was good about it is the fact that they could now start prioritizing what to do next and which boreholes to actually put as the first priority. So these projects, they can be implemented beyond the strategic water sector cooperation between Denmark and South Africa, which is actually ending soon. So it's a continuous thing. It's a continuous improvement on groundwater resource management. I think that's what I can say. Thank you.
Before we move on to the next question, I saw someone had raised their hand earlier on. I think the person was Tando Polo, if I'm not mistaken. I just wanted to ask if you would like to go ahead with your question.
Yes, please. Can you hear me?
Yes, we can.
Okay. Thank you very much to both presenters. That was very informative. Although I come from a civil engineering background, and I saw that slide you had on submersible pumps and concerns around vandalism. So not actually a question, but maybe a comment to you and the rest of your colleagues who work in this space and are concerned with vandalism and theft of pumps, cables, and the sort. There's a product that's in the market which is used in sewer networks. It's called Manhole Protector Grid, so MPG. The person behind it is Chris Kimaru. He works at ISA Partners. They currently have a project that's funded by WRC where they are testing this Manhole Protector Grid in the Free State, which has to do with blockages, but it has the capacity or capabilities to also have a sensor attached to the bottom of it. And the way they install it, the grid and the sensors, because the grid is of value, it's metal, it can get stolen. They remove the manhole rings, install the grid, and then place the manhole rings on top of that grid. And since they've been there, they've seen attempts for vandalism to steal it, but none have been successful at doing so. I think, if you can look at what he has done in sewers, it's something you could also implement in this groundwater space to protect the pumps, cables, and the sorts.
Thank you so much for that, Tando Polo. I would just want to add one more question that just popped up, and this is for you, Dr. G. Can we incorporate new technologies into monitoring? Data science and machine learning were the buzz in the 2010s. Can AI get involved now?
You know, it's kind of funny you say that. When I was working on my M and somebody from my PhD as well, at that time already, people were using fuzzy logic and ANNs, artificial neural networks, and convolutional neural networks, CNNs, to optimize well location, right? That's obviously the underpinning tools of things like AI. And the thing is, we need to begin to understand that AI is a tool in your artillery. It's not a silver bullet, right? And you need to be able to use these tools and obviously various tools to help you make better decisions, right? Kriging is another one. I mean, spatial interpolation techniques. There's one of my PhD students just published a paper around using some of these kind of, hierarchical processes for understanding where to optimize one location for injection and abstraction in a managed aquifer recharge scheme. All of these things are tools, right? And we have to understand that they are obviously in some way, shape, or form some kind of model. And then you have to take a step back and realize that all models are wrong, but some are useful. And that has to be the point of departure. As much as things are moving forward rapidly, you have to know, choose your weapon wisely and see what works, and also calibrating and cross-calibrating. So maybe using GIS and another method next to each other to see, are they talking to one another? Are the data sets the same? Are we calibrating our models properly? The modelers will always tell you about model calibration using things like PEST and manual calibration and these kind of things. So choose wisely and be very careful how you use it. But I will never say no to something that's new, because we have to obviously move with the times to a certain extent, but we have to also just be aware of what's available and how do we calibrate these newer models and tools.
Thank you so much for that, Dr. G. As we close, I'd like to thank our speakers, Dr. Magingi, as well as Dr. Mahed, for their presentations, and to all of you for attending today's session. Your participation and engagement have been fantastic. Before we end, I'd like to highlight that the GWD will be having an upcoming conference, as seen on the slide right now. So I would like to ask that you stay tuned for more details and make sure that you mark this on your calendars. Finally, do not forget to follow the Groundwater Division on LinkedIn to keep up to date with all the events, news, and opportunities for young professionals, as well as our old professionals too. Thank you again for joining us today, and we look forward to seeing you in our next event. I just saw your question now. I do apologize. The presentations will be recorded, and the recording will be uploaded on YouTube at a later stage. Thank you and bye.
Thank you.
Thank you, everyone.
Bye.
Thank you. Bye.